Good day and welcome to Medley School's tutorials. Today we are looking at chemistry, topic electrolysis. Objectives. At the end of the lesson, the student should be able to define electrolysis. And also, the student should be able to state the Faraday's first law of electrolysis. What is electrolysis? Electrolysis is the chemical decomposition of compound which takes place when an electric current is passed through either a solution or the molten form of compound. That is to say, when we talk about electrolysis, it is a chemical change that is brought about by what? By passage of what? Direct current in the what? In the solution or in a compound. And when that happens, you say that electrolysis has what? Taking place. Before we have passage of current in that solution, which must be in molten form, there is what? The ions are what? Are moving what? Freely. In what? In a random position. But whenever there is what? There is a passage of what? Direct current through the what? Through the electrode to the what? To the electrolyte. The ions will do what? We dissociate. That's when we say that there is what we call ionization. So in this context, whenever there is what? Wherever there is a chemical change due to passage of what? Passage of direct current in what? In a solution of what? Of electrolyte. You say that what? Electrolysis has taken place. So that's why we say that it is a chemical decomposition of compound which takes place when an electric current is passed what? Through either a solution or in what? Molten form of what? Compound. For example, when we have our H2SO4, H2SO4 is what? Is an aqueous solution. When you do what? When you pass what? A direct current through the what? Through the electrode, you will see that what? The ions will do what? We dissociate. Before the ions were moving what? In a random what? In a random motion. But once there is a direct current, there will be what? Dissociation of what? Dissociation of ion, and ionization will take place. In that context, you say that what? Electrolysis what? Has taken place. That's why we say is the what? Chemical decomposition of what? Compound, which takes place when an electric current is passed through either a solution or in a molten form. Also, we have scientists that worked on this electrolysis. His name is called Michael Faraday. Michael Faraday propounded two laws. First is what? Faraday's first law of electrolysis, while the second one is what? Faraday's what? Second law of what? Electrolysis. But now we are looking at what? Faraday's first law of electrolysis. He said that the quantity of products liberated at electrodes, because it's through the electrode that what? That current is supplied to the what? To the compound that is what? That is electrolyte. And once that happens, electrolysis will take place. So he said the quantity of products liberated at electrodes during an electrolysis is dependent, must be dependent on one, the magnitude of what? The steady current that passes through it. Secondly, the time of flow of what? Of the steady current. And the third one, you have the what? The ionic charge of the what? Of the liberated element. That is to say, here now we have three factors at which what? The Faraday's first law coined, his own verification. He said that one, the magnitude, there must be the magnitude of the steady current. That is the state or the level of the what? The current that passes through it. Secondly, he talked about the time of what? Of the flow of what? Steady of what? Current. And the third one, he talked about the ionization of what? Ionization of the what? Elements. Because it's when the element is ionized that ions will what? Will be produced. So that's why he said the ionic charge of what? Of the liberated what? Element. So now he states the law, the first law, as the mass of an element discharged during electrolysis is directly proportional to the quantity of electricity passing through it. The mass of an element, the mass of an element discharged during what? During electrolysis, it directly, they don't say inverse, they say is directly proportional to the what? To the quantity of electricity that what? That passes through it. So the quantity of mass that is produced during electrolysis is what? Is directly proportional to the quantity of what? Quantity of current that what? That passes through it. That's why in the first law, it said that this electrolysis now is what? M varies what? Directly to the what? To the quantity of current. Why this quantity of current is what? Can be seen as what we call coulombs. The quantity of current can see as what we call coulombs. So in this coulombs is talking about current times what? Times time. But we shall look at that in time to come. So now, he said that the unit of this quantity of electricity, which is the quantity of electricity, is the what? The coulomb. So now this now denotes the what? The coulomb. So now, this is not measured directly. The quantity of electricity that passes through electrolysis is not what? Is not measured what? Is not measured directly, because now it's denoted with what? With coulombs. In these coulombs is equal to what? Current times time. So you will look at it and see that it is not what? Measured what? Directly. So he said it's not measured directly, but is derived from the what? From the measured rate of flow of electricity. That is to say, the current. So here now we have that current in what? In ampere, and also have time of flow of the what? Of current, which must be in seconds. So therefore he said that coulombs is what? Is equal to what? Current times time. So here now the very first law of Faraday now is telling us about the what? About the product of element in electrolysis. How is what? Directly what? Proportional to the quantity of what? Electricity. And also you know that in this, the quantity of electricity, it is not derived directly, because here we're supposed to have current. But now, instead of getting directly, it is what? Derived. So that's why we have that Q is equal to what? Current what? Times what? Time. And have it in mind that whenever you are asked to do any calculation or any problem involving Faraday's law, you must do what? You must use coulombs as a derived what? Quantity. And using coulombs as a derived quantity, you must do what? You must itemize them, the current and the what? And the time. And make sure that you do what? You substitute any value that is given to you in formula. So with this explanation, I am convinced that whenever you are asked any question pertaining electrolysis and Faraday's first law of electrolysis, you can be able to do what? You can be able to explain what electrolysis is, and also what Faraday's first law is. And also, you must be able to do what? To differentiate between what? The mass that is produced in electrolysis, and also the quantity of current that passes through it. And also you must know that the coulombs we have here is what? Is a derived what? Is a derived quantity. Thank you for watching. See you in the next video.